So I'm going to start off with a question. What technology do you think will change the world as much in the next 25 years as computers and the internet have over the last 25? I like that one, and I was going to look for you when you said that. So robots is something that I think we've all seen. Boston Dynamics has two-legged, four-legged robots that are pretty exciting. There are autonomous vehicles, which is just another type of robot. The largest job category in the United States of America is driver of some kind. Those jobs are going to go away. Virtual and augmented reality. I think you might recognize the Oculus Rift on the left, Magic Leap on the right, a company that's raised $2.6 billion in venture capital. Within the next 5 years, I expect that we're going to have virtual reality that's indistinguishable from what we see around us every single day. Brain-computer interfaces. Neuralink is a very interesting product, a company that was started by Elon Musk. It's the idea that our interfaces with our computers right now are very, very slow. We type with our fingers, we listen with our ears, but it'd be great if we could interface with computers, create cognitive prosthetics. Synthetic biology is the ability to slice and dice DNA using CRISPR and Cas9 to create new types of foods and fuels and pharmaceuticals. But of course, once we can manipulate DNA in that way, we can also make changes to the human genome. Some obviously for very good purposes, but I think there are going to be some ethical concerns with respect to things like enhancing IQ. Reusable rockets are pretty cool. And I know that some of you have children that are really into rockets. And what that enables is taking products and satellites and putting them into low Earth orbit to produce things like the Starlink satellite network. The idea that you could be anywhere on the planet Earth and get high-speed internet connectivity with very low latency, which would have pretty significant implications for education. And of course, energy to drive all of this. And there's lots of innovation in solar cells, hydropower, wind power, and then just a recent announcement out of MIT about a new type of technology that's going to make fission more practical in the coming decade. And then finally, artificial intelligence, which is usually the thing that I think is the go-to for most people with respect to what's going to change the world as much as computers and the internet, the ability to perceive, comprehend, and take action. I could go on with a list, and I'm sure that there are some of the things that you would have put in your list compared to the ones that I just showed. I think what's amazing is all of these things in some way are going to change the world in remarkable ways, and the combination of them certainly will. And it's going to happen very, very quickly. But rather than just guessing and using our hunch, what are some techniques that we can use that are systematic, objective, and evidence-based to make predictions about the future so that we can actually shape the future that we would like? So I'd like to just do a quick run-through of some methods of forecasting technologies. Porter and Rossini back in 1987 took a look and developed a taxonomy of all the different types of forecasting methods, and they found out that there were hundreds of them. But there really comes down to 5 basic families: monitoring, expert opinion, trend extrapolation, modeling, and scenarios. Everything is just a version of those. Monitoring is this recognition that the future is already here, it's just not very evenly distributed. Right? Whatever that technology is that's going to change the world as much in the next 25 years as the internet and computer have in the last 25 is here today in some form, maybe in one of the research labs. One of the challenges of monitoring is just the massive amount of information that's available to us. Right? You go into the internet, you type into Google some search words, and you come back with 5 million hits. How do you find that needle in the haystack? And one approach that I teach to my students is this recognition that there are stages of technological development. First, there is some sort of a scientific discovery, usually happens at a university that we all work at. There's some laboratory feasibility when the researchers are trying to kind of control it, to create some model of it. Then they develop a prototype to solve some sort of a problem, not necessarily driven by customer need, but by what they think they can do with it. Unfortunately, that puts the cart before the horse. Technology before need. But then there is some operational or commercial use that came about, hopefully through some technology licensing, like we've heard about today, and then widespread commercial use if you're really, really lucky and successful. Ultimately, that technology gets diffused to other areas. So back in the early 1960s, lasers were developed, and think about all the different uses for lasers: for range finding, for communication, for surgery, to read and write to optical media. And then people studied the social and economic impact. And maybe, and unfortunately, the negative delayed consequences that weren't anticipated through its development. We need to think about those things early in the development process. But what's interesting about recognizing these stages of technological development is that information about those technologies are available through different channels. So if I wanted to find that needle in the haystack about some new technology, I would think about what stage of development was it at, from basic science all the way through to everyday life. And so information first appears about technologies through funding agencies, right? The National Science Foundation puts out a proposal, and they say, we're looking for people to do research in this area, or DARPA. R&D labs create new technologies and publish reports, and that could be Google Labs, it could be Facebook, it could be any sort of a think tank. Conference proceedings, poster presentations at conferences just like the one we're at today. Competitions are very exciting, right? The X Prize to provide or spur innovation from not just universities, not just private companies, but sometimes private citizens. Then there are academic journals, but we know what the publishing cycle is. It takes a long time to get something published. That's why it's a little bit later down this list. Then the patent database, right? Technologies get patented, and within 18 months of them being filed, those become public disclosures. Lots of very interesting things. And it takes longer than 18 months to get a product to market. So you can oftentimes find about it through the patent database publishing, and then it appears in the market 6 months or a year later. And then finally, industry white papers and media, and this is when people hear about it on the street, right? People just become aware of something like AI that's been around for a long time because something came out in the news or it's in Popular Mechanics magazine. The second approach is a recognition that we can develop expertise and knowledge ourselves through monitoring, but let's go find an expert. Let's just ask them. But the problem is experts are subject, just like we all are, to certain cognitive biases, right? And if you put a bunch of experts together, now you have even more biases through groupthink. So James Surowiecki, who wrote a book called The Wisdom of Crowds, said paradoxically the best way for a group to be smart is for each person in it to think and act as independently as possible. And this is an idea about applied cognitive psychology. How can we use what we know about how human beings think to help them to think more rationally, think with less biases? There's an organization called RAND, which stands for Research and Development, very clever name, that said the Delphi method was devised in order to obtain the most reliable consensus of a group of experts by subjecting them to a series of questionnaires, in depth, interspersed with controlled opinion feedback. This is in 1951, and that's essentially the essence of the Delphi method. How can we collect information from a group of people in a systematic way to reduce bias? And the approach is very simple, and I'm going to go through it quickly. The moderator identifies a theme and recruits experts. The moderator may not be an expert in this area, but says, hey, I'd like to know something about quantum computing. I'd like to know something about AI. I'd like to know something about synthetic biology. Let's go find some experts, and then you tell me what things we should forecast. The experts identify events associated with that theme. The moderator consolidates those events and then sends out the questionnaire. Here's a list of 10 things in this particular field. When do you think they're going to happen? The experts forecast a date for each event. The moderator runs statistics on those dates and sends them to the experts. Here's the average date. Here's the range. Now, would you like to revise your estimate? Experts can update their estimates, and if they are an outlier, they're required to provide some sort of an explanation. The moderator runs statistics again, sends out the explanations provided by the experts, and again, experts can keep their estimate or modify it based upon the new information. Finally, that information is consolidated in a report and sent out to everybody. This is a pretty simple approach that uses anonymity, iteration, statistical feedback to reduce bias when developing consensus among experts. And in a recent Delphi forecast from 2016, actually in the world of AI, this is an ancient forecast, experts expect that by the year 2040, within that 25-year range I was asking about, high-level machine intelligence will be more likely than not. And this is what I talk to my students about. Within your lifetime, for sure, we will have computers that are more intelligent than you at pretty much anything you can do. And some of you might be suspicious of that, but today I already have a cell phone in my pocket that is way smarter than me at mathematics, way better than me at playing chess. And what we keep doing with AI is keep expanding the types of things that it can do to the point where it's going to have pretty serious implications on the types of jobs that are available. The third approach is called trend extrapolation. Here's a photo of Vinod Khosla, who is a co-founder of Sun Microsystems, founder of Khosla Ventures in Silicon Valley. He said, future is not an extrapolation of the past. And that's true, because trends are only true into the future when we extrapolate them if nothing changes. Yet things change all the time. But that doesn't mean it doesn't tell us anything. We just have a general trajectory. Then we have to make some modifications based upon external realities. Trend extrapolation really came from this idea of growth curves. You put a cow onto a scale, you plot the data of its size week by week, draw a line through that data to create the best fit curve. And if you do this with a number of types of animals, you come to this recognition that there is a universal growth curve for animals. Right? We have dimensionless time across the bottom because not all animals live the same lifespan. They're not all the same weight, but they have a mass ratio. And we see regularities. And this is what's so exciting about trend extrapolation, is that I could talk to you about a dozen different types of regularities that we see in nature. Some are logarithmic, some are exponential, some are linear. And if we know about those types of regularities and we understand what's driving those, we can, through extrapolation and through analogy, apply that understanding to new phenomena to make predictions about the future. One of the most common observations, and I'm sure most of you have heard of this, is Moore's Law. Back in the 1970s, a gentleman named Gordon Moore said that the number of components initially, but then transistors eventually, the number of transistors will double every 2 years. And that has been true for 50 years. And every decade, people bet against it. Moore's Law is dead. But Moore's Law continues and continues into the 2020s. Now people say Moore's Law is dead, just you wait. And I just keep placing my bets that it won't. Now someday, I'll probably lose that bet, but not for a few years. We just are very clever at coming up with new ideas. And sometimes we cheat with quantum computing, we change the rules of the game, and we continue on. We see different types of curves. Here's an example of what's called a substitution curve. In the early 1900s, most people got around town by riding horses. But then the automobile was invented. And slowly, people transitioned from riding horses to driving cars. And this is a very common set of substitution curves. And we see this in lots of different industries. I love this one because this is a type of substitution curve where people used to move goods through canals. But then they switched to railroads. And then they switched to roads. And then they switched to airways, right? This is how we move things around as we develop new technologies. But when you see a graph like this, don't you, like I do, think, what's next? So what's next? My bet is reusable rockets of this type. And so Elon Musk and SpaceX is producing this Starship rocket. It will be tested in a couple months. And imagine being able to go from any 2 points on the planet within 1 hour. How would you like to be able to fly back to Vienna from Washington, D.C. in about 45 minutes? For real. Like, this technology is being developed right now and will happen in the next few years. And it will displace a lot of movement of goods and people. 1/4 of the cost to produce one of these vehicles, 20 times the speed. Another area is artificial intelligence, One application of that is called GPT-3 from a company called OpenAI. Really interesting stuff. And the reason I bring this up is you, again, can make an extrapolation about the future. So here is an example of the different types of technologies that basically you can have a conversation with your computer. On the vertical axis, you'll notice that it's on a logarithmic scale. It's on a linear scale across the horizontal axis. That straight line indicates exponential growth. And I can make a projection, and this is my wager, we can come back and check it out a little bit later, about this time next year, we will have GPT-4, which will have 100 trillion parameters, which is coincidentally the same number of synapses within the cerebral cortex of the human brain. Now, that doesn't mean it's as smart as a human being, but when it comes to something like communicating with your computer, it's pretty amazing. And I have to think about this as a teacher because kids are going to be using this to write their essays. And they're going to be great essays. That's probably how I'll be suspicious, right? That's how I catch a lot of plagiarism too. And how is this going to get faster? By using microprocessors like the one on the left. You can barely see the one on the bottom right. Did you see that one down there? That was the current largest GPU. This is a CPU that has 2.6 trillion transistors. And of course, what would a slide be in a presentation about technology without Elon Musk's company? So he's doing some of the most sophisticated work in AI. And this time next year also, he will have one of the fastest supercomputers on the planet, dedicated solely to training AI systems. That's what this supercomputer is going to do. The fourth method of technology forecasting is called modeling. It's sort of an offshoot of trend extrapolation. Once we understand what these trends are, the underlying scientific mechanism or phenomena that drive those, we can create models. And the models allow us to explain, predict, and ultimately shape the future. Now, all models are wrong, and some are useful. By wrong, they're simplifications of the world, right? We don't catch all the nuances. But they're useful in that they allow us to hopefully change the future to what we'd like it to be. And some examples include climate change, right? We model what's happening, we make predictions, and hopefully we can shape it. The COVID-19 pandemic, right? We see the waves coming, and all of us who are pretty sophisticated understand when a wave starts to take off and it starts growing exponentially, this thing is not going to just stop. It's going to continue, and we can make predictions about that. And of course, replacement migration in Austria. So if you have questions about this, you can ask the professor in the front row. But we want to understand, because we have a big ship and a very small rudder. And if we want to change things in the future, we have to turn that rudder pretty early. And finally, the fifth method is scenario development. Seneca said back 2,000 years ago, whoever does not know how to take care of the future and the present will depend upon the uncertainties of that very future. Basically, we want to be proactive instead of reactive. And scenario development is very, very common, but I think it draws upon that interdisciplinary character that we've discussed in so many of the presentations. This happens to be the mnemonic that I teach to my students. The great thing about learning German is that the words are much, much longer, so I can include other types of external factors into this. But this is what's great about having people involved in the scenario development process who bring different types of knowledge and perspectives to the process of technology forecasting. It's used in industry by McKinsey & Company. It's used by the European Commission to develop forecasts and scenarios of the future. And what it allows is what's called backcasting, this idea of we create a vision of some possible future and we say, how can we get there from here? So back in the early 1960s, in the very early months of John F. Kennedy's presidency, he said, I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely. This is an example of a politician recognizing that there's a possible future, getting the public behind it, getting the funding for it, and then coming up with a plan to get us from here to there. And it happened within a decade. Walter Gretzky, who like many parents was a coach to his son, Wayne Gretzky, who was arguably the greatest hockey player of all time, said, skate to where the puck is going, not to where it has been, right? And any of you who've played sports where there's some ball on the ground, if you just try to chase that ball to where it is, you're just going to get tired. But if you watch the play develop, and you see something sneaking over on this side, and you watch the ball over there, you think, I can see where this is going. And you run to where the ball is going to be and intercept it. That's what technology forecasting allows us to do, to skate to where the puck is going to be. So this is my proposal to promote innovation and tech transfer. We would like to say tech transfer is like this, right? We've got academia on the left, racing along, passing the baton of some new innovation to some commercialization partner, and no loss of speed. Unfortunately, what we often see is this. And I love the picture, the face of the man in the front, right? That's what sometimes happens in technology transfer. The baton gets dropped. And I think part of it is because of the way it typically happens. And I used to work in my university's technology transfer office, so I've seen it from both sides, actually, as an inventor and then as someone who's licensed technology. It's typically a very serial process, right? And then you notice that vertical line there. I intentionally drew it to look like a brick wall. That's a little cynical, I know. But the problem is that a lot of these technologies get developed and then marketed to people who didn't necessarily ask for it and say, this is what we want, and this is the way that we want it. And I think what would work much, much better is if we got people together a little bit earlier. This happens to be two real teams, one in Canada, one in Silicon Valley. They sort of look like each other also, just different jackets. And if we could get them, instead of waiting until the technology got developed and then passing it hopefully over this big brick wall and not dropping it on the way, but very, very early in the process, much earlier than I think most people would be comfortable with, working together using something like a technology forecast. Let's share our different perspectives. Let's talk even before you've begun doing some of your research. Let's monitor. And I can tell you, academics monitor different things than people in corporate America. When's the last time an academic monitor went on to Google Patents to see what they were going to include in their lit review? Academics don't go to Google Patents. Just like many people in corporate America don't go to Google Scholar. Right? There are a few people in the company that do that. They monitor different sources of information. The Delphi method. Remember how we want experts that have different perspectives? Or trend extrapolation. There's different trends that people in corporate America look at compared to the scientists that understand the underlying scientific principles. The same with modeling and scenario development, especially with scenario development. And I think the third party that can make this happen is the government. Right? I think that they can coordinate, moderate, and hopefully, and especially participate in this process at conferences just like this one, right? And if we can get the university together with industry and government with their shared perspectives, working together to create a shared vision of the future, we can use that backcasting technique to figure out how to get from here to there, where everyone is contributing what it is that they do best. So that's what I like to see happen, and hopefully, and I don't want to be too presumptuous, maybe ARIT 2022 or 23, we might have the opportunity to do that. Thank you very much.